India, home to over 1.2 billion people, is continuously growing and expanding its economy and standard of living. The rapid urbanization, population growth, technological boom, and industrial automation are posing an enormous challenge to the water and sanitation situation of the country. The flush-and-forget approach of the conventional sanitation systems does not offer a sustainable option to solve the sanitation crisis. Currently, only 21% of all the wastewater in India is treated and the remaining 79% is left untreated. Innovative and unconventional technology solutions are required to improve the above situation. NaWaTech project is one step further in this direction. This Indo-European project aims to explore, assess and enhance the potential of natural and compact water treatment systems in order to improve their performance and reliability in the urban Indian context. NaWaTech Consortium assessed multiple technologies, out of which a few were decided to be most suitable for implementation. The first are the anaerobic systems comprising of anaerobic settler, similar to a septic tank, anaerobic baffle reactor and anaerobic filter. The last two consist of a series of chambers which provide adequate retention time and allow the wastewater to flow upwards. This encourages the contact with the anaerobic bacteria that decompose the organic matter. The anaerobic filter provides extra surface for the bacteria to attach, allowing further treatment efficiency. One example of these treatments has been implemented in the hostel of the College of Engineering, Pune, that hosts 2,000 students. COEP is the largest site under the project, treating 180 cubic meters of wastewater per day in 3 separate units. Anaerobic systems have been combined with constructed wetlands to enable the reuse for gardening and flushing purposes. A different configuration can be seen at the ordnance factory in Nagpur, where a total of 100 cubic meters of wastewater is being treated with an upflow attached growth anaerobic filter. As a polishing treatment, a combination of horizontal subsurface constructed wetlands, French wetlands, sludge drying reed beds and short rotation plantations have been implemented. Constructed wetlands are man-made systems that mimic many of the conditions and processes that occur in the natural environment. These consist of planted beds of gravel and sand that treat wastewater by a combination of biological and physical processes. As the water flows through the wetland bed, the organic load is reduced as it comes in contact with the bacteria attached on the sand and gravel. Simultaneously, the plants might uptake some nutrients, further improving the quality of water. Depending on the flow regime and the application, there are different types of constructed wetlands, such as the horizontal flow, vertical flow, and the hybrid that combine different wetlands. An excellent example of different combinations of wetlands has been established at Dayanand Park, Nagpur. The treated water from this system will be used for landscaping in the park. A modification of the constructed wetlands is the eco-filtration bank with soilscape filter. A soilscape filter is a vertical system where wastewater passes through the layers of gravel, sand, and bioactive soil consisting of microbial consortia, where the pollutants are absorbed and degraded. This system was implemented at Indradhanushya Environment and Citizenship Centre, Pune. Another implementation using similar principles as the wetlands is the vertical garden at the Maharashtra Jeevan Pradhikaran. This system comprises 2 parallel vertical gardens treating grey water from the office building. It shows that natural systems can work with a smaller footprint area while also being integrated into the aesthetics. In addition to natural systems, sequence batch reactors (SBR) and membrane bioreactors (MBR) have been assessed within the NaWaTech project. In a membrane bioreactor system, the membranes are submerged in an aerated biological reactor. First, the wastewater enters in contact with the aerobic microorganisms and then passes through the membrane, eliminating the need for sedimentation. This combines conventional activated sludge processes with membrane filtration to provide an advanced level of organic and suspended solids removal. The sequencing batch reactor is a different configuration of the conventional activated sludge systems in which the process can be operated in batches in the same reactor but at different times. The treatment cycle starts with the filling of the reactor with wastewater. Next, during the reaction stage, the wastewater is aerated and bacteria oxidize the organic matter. Thereafter, aeration is stopped to allow the sludge to settle. In the next step, the water and the sludge are separated by decantation and the clear layer is discharged from the reaction chamber. These two technologies have been implemented at Amanora Park Town, Pune. The system is set up in a 50 square meter space and is completely automated. The SBR and MBR are installed in parallel and treat 40 cubic meters of wastewater per day.
NaWaTech is one of 7 framework projects of Department of Science and Technology, Government of India and European Commission. Implementation of various greywater and wastewater technologies in Nagpur and Pune are central to this particular project. We are extremely thankful to Department of Science and Technology, Government of India, Indian and European partners and other stakeholders who had allowed us to implement these technologies in their own premises. Thank you.
The NaWaTech consortium, composed of 7 Indian and 7 European partners, hopes that these case studies would serve as examples and inspiration for engineers, entrepreneurs and researchers across India, taking the country towards a greener economy. NaWaTech is an Indo-European research and development project funded jointly by the Government of India's Department of Science and Technology and the European Commission through its 7th Framework Programme.